What is a number system? Basically, number system is a language of digital system which consists of set of symbols or digits. Number systems are basically two types. First one is a positional number system. Second is a non-positional number system. So first one is a positional number system. In a positional number system, the position of each digit of number has some positional weight. In this category, binary number system, decimal number system, octal number, hexadecimal number, etc. are example of positional number system. We always use decimal number system in our daily life use. So decimal number is simple example of positional number. So why this number is called positional number, I will explain here. So you see the example one. I'm writing one decimal number 2689. Okay, so we can rewrite this expression like 2 is equal to 10 to the power 3 plus 6 into 10 to the power 2 plus 8 into 10 to the power 1 plus 9 into 10 to the power 0. 6 into 10 to the power 2 plus 8 into in decimal number 2689. If we see this symbol 2, positional weight of this 2 is what? This positional weight of 2 is 10 to the power 3. So here is everything. So similarly, positional weight of 6 is 10 to the power 2, that means 100. Positional weight of 8 is 10 to the power 1. And last one in this number 9, positional weight of this one is 10 to the power 0, that means unity. So every symbol in this number, every symbol has its own positional weight. Here for positional weight of 2 is 1000, positional weight of 6 is 100, positional weight of 8 is 10, 9 is 1. So every symbols or digits used in any number, its weight basically depend on at which place every symbol has been placed. Okay. Next example, I am taking decimal number 5.203. This number 5.203. We can rewrite this expression like this: 5 into 10 to the power 0 plus 2 into 10 to the power minus 1 plus 0 into 10 to the power minus 2 plus 3 into 10 to the power minus 3. We can rewrite this one. So in this decimal number, if we see this symbol 5, so what is the positional weight of this 5? So here positional weight of 5 is unity 10 to the power 0. Similarly here after fractional point or decimal point, this symbol is used here 2. So what is the positional weight of this 2 is 10 to the power minus 1. Similarly symbol 0, positional weight of this one is 10 to the power minus 2. And last symbol used in this number is 3. So positional weight of this one is 10 to the power minus 3. So every digit or symbol in positional number system having its own positional weight. So every symbol having a positional weight in a positional number system. Second is non-positional number system. In a non-positional number system, a digit of a number does not indicate any significant positional weight. Example of this one, we done in our school life. Roman numbers, we written their Roman number. So Roman number is a example of non-positional number system. Then gray code, XS3 codes are also example of non-positional number system. So what is gray code and XS3 code? I will discuss this one in a later lectures. Okay. So in a non-positional number system, I hope every student have a clear concept in this. In a non-positional number system, digits or symbol having no any positional weight. Okay. Next, a number is constructed by a collection of digits. So every number has two parts. So it has a two parts: integer and fraction. Both are separated by a radix point, and this radix point is known as a, we are saying, decimal point. So this is a general format of a number. If we are writing any number, so this is a radix point in this between any number, and on the left side of this radix point, this one is called integer part. This is called integer part. Here on the right side of radix point, this one is called fractional part. This is fractional part. Fractional part, and after this, okay, if you see the this leftmost bit dn minus 1, this one is called MSD. MSD means most significant digit. And here rightmost bit d minus m, this one is called LSD, that means least significant digit. So where here E symbol, where dn minus 1 to dn minus 2 dash d1 d0 all are known as the integer digits in this format. Similarly, d minus 1, d minus 2 up to the d minus m, making a fractional part of this one. So these are fractional digits. Digit dn minus 1, this one is known as a most significant digit. And last digit d minus m, this is called least significant digit. So what is a MSD and what is a LSD? Most significant digit and least significant digit. What is this? So I will explaining this one. If I am writing any number, for example 568, okay, any decimal number 568. So what will happen here? Which one is called MSD? So this 5 is called basically MSD. Why? I will tell you. And this is called 8 is called LSD. If this 568 number, if we change this 5 by any other number of decimal, this is 4. So now this picture or this value become a 468. Now magnitude will change by 400. Oh, sorry, 100. Now if we change this 8 here, if I am changing this 8 by any decimal number system, for example I am taking here 1, so now new number become 561. So if we see, if we are changing a rightmost bit, then the magnitude affected less. If we are changing a leftmost bit, or we can say first digit or bit of number, then that time magnitude is going to change larger. That's why this first bit is known as a MSD and last bit of any number is known as a LSD. Because if we are changing in a LSD, then overall magnitude is going to change in a minor amount. If we are changing a MSD, that time overall magnitude will change larger. That's why we are saying first bit as a MSD and last bit of any number is known as a LSD. Now the types of number systems. Types of the following number systems are used in digital systems. First one is binary number system, second is octal number system, decimal number system, and hexadecimal number system. These number systems are widely used in digital systems like microprocessor, logic circuits, computers, etc. And therefore, the knowledge of these number system is essential for understanding, analyzing, and designing of digital circuits or systems. So first I will explain here binary number system. So binary number system base is 2. Binary number system is base 2. Every number system having a standard number system having a its own base. So binary number system base is 2. This base, so base is 2. So this base indicating a total number of digits or symbol used in that number system. If base of this one is 2, so second point, if you see, so there are total 2 different digits or symbols in binary numbers because base is 2. That's why this number system having a 2 different digits or symbol. In binary number, only 2 digits are used, that is 0 and 1. So binary number system is 2. So total different digits will be a 2. So that digit or symbol will be a either 0 and 1. Highest value of digit in binary number system is 1. If you see, in binary number 2 symbol 0 and 1, so highest value is here 1. So that's why I am writing here 1. The example how we will write any binary number system. If you see 10101 base 2, that means if you see this example, so this example, yeah, this number consists of only 2 symbol. This one is a 0 and 1. Similarly, this one 0 1. So in binary number system, number can be represented using a 0 and 1 only. Next one is octal number system. Octal number system base is 8. Octal number system base is 8. So there are total 8 different digits or symbols in octal number. Okay. In octal number, 8 different digits are 0, 1, 2, 3, 4, 5, 6, and 7. So total symbols are 8. These are. So highest value of digit in octal number system is 7. See, if you from 0 to 7, the highest value is this one, 7. So highest value of digit in octal number system is 7. Example of this one is 257 in octal number. This 8, this 8, this number is indicating the our number is written in an octal form. So next example, if we see 1257.035, this is octal number. Similarly 0.25. So in this example, if you see, all in this example numbers use from 0 to 7. Beyond these range, we are not we cannot use any symbol in octal number. Okay. Now decimal number systems. Decimal number system base is 10. So there are total 10 different digits in decimal number system. This decimal number system we are using in our daily life. Okay. So we are already aware in decimal systems there are total 10 different digits, and that digits will be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are total 10 different digits. So highest value of digit in decimal number is 9. So in the example of this one, 3589 base 10, 0.125 base is 10. Last one, 10101.356 base 10. So see these three examples, this one and this one. These examples consist of using these 10 different digits. Okay. Last one is hexadecimal number system. So hexadecimal number system base is 16. So there are total 16 different digits in hexadecimal numbers. And so in a hexadecimal digits will be here 0, 1, 2, 3, 0 to 9. These will be a total 10 digits. And after 9, 10, 11, 12, 13, 14, 15. But we cannot write here 10 as a 10. So 10 will be represented by A, 11 will be represented by B, 12 will be represented by C, and similarly 13 by D, 14 by E, and 15 by F. So always remember, whenever we are writing any hexadecimal number system, 10 will be represented by A, 11 will be represented by B, and up to the 15 we can write by F. So in hexadecimal number system, 10, 11, 12, 13, 14, 15 are represented by alphabets A, B, C, D, E, and F respectively. So highest value of digit in hexadecimal number system is 15. If we see 0 to 15, so 15. So we cannot write here a 15 as a decimal value. So 15 will be written by here English alphabet F. So highest value of digit in hexadecimal number is F. So example of this one, if we see BABA, base 16, base is indicating this BABA is representing a hexadecimal number system. Next example 2A90.45 base 16. So if you see, so in this one we use a symbol from 0 to F. Okay, any number we can use. So last example 0.B45 base 16. Note, base of about note here is I'm going to tell about importance of base. So base of any number system represent total different digits or symbol used in that number system. This is the first point. Second point, if we know base of any number system, then we can determine highest value of digit in that number system. If we know the base of any number system, then we can also determine the range of digit in that particular number system. If I'm saying base of any number system is 16, that means this is a hexadecimal. So digits will be from 0 to 15. If I'm saying base of any number system is 12, so for base 12, symbols or digits will be from 0 to 11. But remember always 10 will be represented by A, 11 will be represented by B alphabet. Okay. So I have a one problem for all of you. See question, this one, question 1. From given following numbers, find which number is valid and invalid. So Find which number is correct or incorrect. If we see here, first example, this first problem, 10010.01. So identify first what is the base of that number. So if we see here, base of this number is 2. So in base 2, we can use, in base 2, symbols will be, symbols we can use 0 and 1. So number consist using these symbols only. If you see, so here is 0 and 1 use, so this one is correct or valid number. So first part is valid number or correct number representation. This is okay. If you see the second part, this second part is, if you see, base is 8. So base 8 means symbols will be, here will be in this one is from 0 to 7. Symbols we can use here, symbols we can use from 0 to 7. So here you see 2 is correct, 5 is also correct, but 8 is not correct. 8 cannot be in a octal number because highest value in octal number will be a 7. So 8 is wrong number here. So we can say second example it representing a invalid number. Okay, invalid or incorrect number. Third C, base of this one is 10. So symbols we can use in this one is in decimal. Symbols we can use from 0 to 9. So here all numbers 2, 3, 5, then point, decimal point, then 8 and 9. These all are valid digits, okay, in decimal number system. So we can say this third problem is correct. This is correct, this is incorrect. Fourth one, see the base of this number. Base of this one is 16. So symbols we can use in this one, symbols will be from 0 to 9. Then after 9, A to F. A to F. So see here, BA10.10. All are symbols or digits used in a hexadecimal. So this is also correct or valid number. And last one, if you see, this is binary number. Binary number base, I already told you ki base is 2. So in this one, symbols will be either 0 and 1. So you see here, 1 correct symbol, 0 is correct symbol, 0 is correct symbol, but 2, this is wrong symbol. In a binary number, we cannot use 2 as a symbol. So this is invalid number. So